22 of 34 vital signs. Not 22 out of 34 opinions, not 22 out of 34 projections, built on a model running 50 years into the future. 22 out of 34 measured, recorded, verified physical indicators of planetary health sitting at record levels right now, published in a peer-reviewed scientific journal by more than a dozen of the most cited climate scientists alive. That is the sentence that opens this story, and it is not an exaggeration, and it is not clickbait. It is a direct quote from the 2025 State of the Climate Report, written by William Ripple, Christopher Wolfe, Michael Mann, Johan Rockström, and their colleagues, published in the journal Bioscience. And it is only one of 4 warnings that have all independently in different labs, from different research teams, using different data sets, arrived at strikingly similar conclusions within months of each other. 4 separate alarm systems, 4 separate teams of scientists who did not coordinate with one another. And yet all 4 converged on the same basic message, delivered almost simultaneously, as if the planet itself had tripped 4 different smoke detectors in 4 different rooms of the same house, all in the same week. This is not a story about a single disaster. There is no earthquake here, no single hurricane, no single headline event you can point to and say, there, that is the crisis. This is a story about convergence. It is about why 4 completely separate scientific monitoring systems, tracking 4 completely different aspects of the Earth, all began flashing red at nearly the same moment. And once you understand why that happened, you start to understand something more unsettling than any single disaster could tell you. You start to understand that the planet's warning systems are not 4 separate stories. They are one story, told 4 times, from 4 different angles, because the underlying system they are all measuring is the same system, and it is the same system that is now under stress in every direction at once. Let's start with the one that surprised even the scientists who found it, because it involves the ocean, and specifically, it involves a boundary that had never been crossed before in the entire history of modern environmental science. In the spring of 2026, the Potsdam Institute for Climate Impact Research published the 2nd edition of what is known as the Planetary Health Check. This is an annual assessment built on a framework called planetary boundaries, first proposed back in 2009 by a group of Earth system scientists led by Johan Rockström. The idea behind planetary boundaries is elegant and a little terrifying once you sit with it. There are 9 processes that keep Earth in the stable, livable state that allowed human civilization to develop over the last 10,000 years, a period scientists call the Holocene: climate, biodiversity, freshwater, land use, ocean chemistry, aerosols, ozone, novel chemical pollution, and the flow of nutrients like nitrogen and phosphorus through the biosphere. Each of these 9 processes has a boundary, a line that, if crossed, does not mean instant collapse, but means humanity has left the safe operating space that kept the planet stable enough for agriculture, for cities, for the climate patterns we built our entire civilization around. In 2009, 1 boundary had been crossed. By 2015, 4 had been crossed. By 2023, 6 of the 9 had been transgressed. And now in the 2025 Planetary Health Check, published in May of 2026, the count has risen to 7. The newest boundary to fall is ocean acidification. For years, ocean acidification sat right at the edge, a boundary under pressure, but technically still inside the safe zone. Then, in late 2025, it tipped over. The mechanism is simple chemistry, and it is relentless. The ocean absorbs roughly a quarter of all the carbon dioxide that human activity puts into the atmosphere. That sounds like good news because it means less carbon dioxide stays in the air to trap heat, but that carbon dioxide does not vanish once it enters seawater. It reacts with water to form carbonic acid, and that acid lowers the pH of the ocean, making it more corrosive to the calcium carbonate shells and skeletons that shellfish, corals, and tiny drifting organisms called pteropods depend on to survive. Pteropods might sound like an obscure detail, but they sit near the base of the marine food web, feeding fish that feed larger fish that feed, eventually, an enormous portion of the human population that depends on the ocean for protein. When you weaken the base of a food web that supports billions of people, you're not talking about an abstract environmental statistic anymore. You are talking about a hidden foundation of the global food system starting to crack. It helps to understand what a boundary being crossed actually feels like from the inside, because it is almost never a single dramatic event. Nobody wakes up to a headline announcing the exact hour the ocean tipped into the acidification danger zone. Instead, monitoring buoys and research vessels keep logging pH measurements year after year. The trend keeps sliding in the same direction. And at some point, the running average crosses a line that scientists agreed upon years earlier as the outer edge of safety. The crossing itself is almost administrative. The consequences are not. Coral reefs that support an enormous share of marine biodiversity are already showing measurable declines in their ability to build and maintain their calcium carbonate skeletons. Shellfish fisheries in several coastal regions have already reported production losses tied directly to more corrosive coastal waters. None of this required some dramatic cliff edge moment to start hurting people and economies. The damage from crossing a boundary begins accumulating well before anyone can say with certainty exactly which year it happened. With ocean acidification added to the list, only 2 of the 9 planetary boundaries remain in what scientists call the safe zone. Aerosol loading, meaning air pollution particles in the atmosphere, and the stratospheric ozone layer, which is actually recovering thanks to the Montreal Protocol, one of the few unambiguous success stories in the history of international environmental cooperation. Every other boundary, climate change itself, biosphere integrity, land system change, freshwater change, the novel entities category that covers synthetic chemicals, microplastics, and pharmaceutical pollution, biogeochemical flows, and now ocean acidification, all 7 of them have been crossed. Johan Rockström, who co-authored both the original 2009 framework and this latest health check, put it in stark terms. He said more than 3/4 of the Earth's support systems are no longer operating in a safe zone, and that humanity is pushing beyond the limits of a safe operating space, increasing the risk of destabilizing the entire planet. Here is why this first warning matters beyond the raw number of boundaries crossed. Planetary boundaries were never designed to be 9 separate, unrelated report cards. They were designed as an early warning system for tipping points, meaning thresholds where change stops being gradual and starts being sudden, self-reinforcing, and in some cases irreversible. The scientists behind the framework describe these boundaries as interconnected, capable of triggering each other in a cascade. Cross one, and you increase the pressure on the next. Destabilize the next, and you increase the pressure on a third. This is not a metaphor. It is a mechanical description of how Earth's systems are physically linked to one another through moisture, temperature, ocean currents, and carbon cycling. And that interconnection is exactly what shows up in the second warning, which involves an ocean current system that most people have heard of only vaguely, usually in the context of a disaster movie, but which is now the subject of one of the most consequential and sobering findings in recent climate science. That current system is called the Atlantic Meridional Overturning Circulation, usually shortened to AMOC. Think of it as a vast conveyor belt of water that moves warm surface water from the tropics up toward the North Atlantic, where it cools, becomes denser, sinks, and flows back southward at depth, only to warm again and rise near the equator, completing the loop. This circulation is one of the primary reasons why Western Europe enjoys a climate far milder than its latitude would otherwise suggest, and it plays a central role in distributing heat, and therefore stabilizing weather patterns across the entire Northern Hemisphere. Scientists have worried for years that a warming climate, by melting Greenland's ice sheet and pouring fresh water into the North Atlantic, could weaken this circulation, because fresh water is less dense than salt water and interferes with the sinking process that drives the entire loop. What changed in 2026 is not the general worry. It is the specificity and the finality of a new finding. A study published in 2026 in the journal Communications, Earth and Environment, led by researchers including Nian, Willeit, Wunderling, Ganopolsky, and again Johan Rockström, modeled what happens if the AMOC does collapse. And the central finding is this: if the circulation collapses, it will almost certainly never recover, as long as atmospheric carbon dioxide concentrations remain above 350 parts per million. That number, 350 parts per million, is worth sitting with for a moment because current atmospheric carbon dioxide levels are around 425 parts per million and climbing. In other words, we're not looking at a future threshold we might approach and then decide collectively to avoid. According to this research, we have already passed the atmospheric conditions under which a full AMOC recovery would even be physically possible if the collapse were to happen. The circulation is still running today. It has weakened measurably compared to its pre-industrial strength, but it has not collapsed. The warning is not that collapse is happening this year. The warning is that the safety net underneath the potential collapse, the idea that if it did happen, we could eventually reverse it by bringing emissions back down, has already been removed. We have built a system where, if this particular domino falls, there is currently no realistic path back. And this is where the interconnection between warning 1 and warning 2 becomes impossible to ignore. Remember, the planetary boundaries, scientists describing tipping points as linked in a cascade. They gave a specific example, and it is almost eerie how directly it matches what the AMOC study describes. Sustained carbon dioxide concentrations around 420 parts per million, which is essentially where we are right now, would likely produce warming of 2.5 to 3 degrees Celsius, warming that could trigger the collapse of the Greenland ice sheet and the subpolar ocean circulation gyre. The collapse of either of those systems could then destabilize the AMOC, and the collapse of the AMOC, in turn, could push the Amazon rainforest past its own tipping point, because the AMOC helps drive the moisture patterns that keep the Amazon a rainforest rather than a drying savanna. A dieback of the Amazon would then release enormous amounts of stored carbon back into the atmosphere, accelerating warming further, which would then increase pressure on the remaining planetary boundaries, including the ones still barely holding on. This is not 4 unrelated warnings. This is one mechanical chain, described independently by 2 different research efforts, arriving at the same causal pathway from 2 different directions. The planetary boundaries framework describes the chain in the abstract. The AMOC study describes one specific critical link in that chain in devastating physical detail. Different papers, different lead authors even, overlapping team members, same underlying Earth system, same emerging picture. Now to the third warning, and this one comes not from a single specialized study, but from the broadest possible survey of the planet's condition, the kind of report that tries to take Earth's temperature in the most literal and figurative sense at once. This is the State of the Climate Report for 2025, the 6th annual edition of a series that began in 2020, published in the journal Bioscience, and authored by an international coalition of more than a dozen scientists, with contributions from institutions including Oregon State University and the Potsdam Institute. This report does something the previous 2 do not. Rather than tracking 9 planetary boundaries or one specific ocean current, it tracks 34 separate vital signs of the Earth system, indicators spanning the atmosphere, the oceans, energy use, ecosystems, and global food systems. And of those 34 vital signs, 22 are currently sitting at record levels. Not near record, not concerning. Record, the highest, or in some cases the lowest, ever measured. Some of these records are the ones you would expect. The year 2024 set a new record for global mean surface temperature, and the report notes it was likely the hottest year in at least the last 125,000 years, a span of time that predates not just industrial civilization, but the entire history of agriculture, writing and settled human society as we know it. Ocean heat content is at an all-time high. Sea ice loss is at record levels. Wildfire-related tree cover loss is at an all-time high as well. But some of the records tracked in this report are less about the physical climate and more about the human systems driving it, and these are, in some ways, the more uncomfortable numbers. Fossil fuel energy consumption hit a record high in 2024, with coal, oil, and gas all simultaneously at peak levels of use. Combined solar and wind energy consumption also set a new record in the same year, which sounds like good news, until you hear the comparison the report makes directly. That renewable growth, record as it was, remained 31 times lower than fossil fuel energy consumption. Population, livestock numbers, meat consumption, and global gross domestic product are all simultaneously at record highs too, with the report noting that roughly 1.3 million additional humans and 500,000 additional ruminant livestock are being added to the planet every single week. Atmospheric carbon dioxide itself is at a record level so far in 2025, a rise the authors link partly to a sudden drop in how much carbon land ecosystems are able to absorb, worsened by El Nino conditions and intense forest fires that both release stored carbon and reduce the vegetation available to reabsorb it in the future. The authors of this report do not write like people trying to generate headlines. Scientific reports rarely do, and yet the language in this one is unusually direct for a peer-reviewed academic paper. They write that humanity is hurtling toward climate chaos, that the planet's vital signs are flashing red, that the consequences of human-driven changes to the climate are no longer future threats, but are here now. They describe almost every corner of the biosphere as reeling from intensifying heat, storms, floods, droughts, or fires. And they specifically flag warming as an accelerating process rather than a steady one, suggesting that reduced aerosol cooling, meaning the paradoxical loss of some cooling effect that came from certain forms of air pollution as that pollution is cleaned up, combined with strong cloud feedback effects and what they describe as a darkening planet, meaning changes in how much sunlight Earth's surface reflects versus absorbs, may all be working together to speed up warming beyond what earlier models expected. This is warning number 3, and notice again how it does not stand apart from the first 2. The State of the Climate Report explicitly discusses the AMOS as one of the critical tipping elements it is watching, describing the accelerating climate crisis as presenting a range of deeply interconnected risks to the planet's essential operating systems, from that ocean current system to the integrity of Earth's living biosphere to the stability of global water resources. 3 different reports, 3 different primary focuses: planetary boundaries, 1 ocean current, 34 vital signs. And in every single one, the authors stop to point out that the risks they are individually tracking do not exist in isolation. They keep describing the same underlying architecture, a planet whose stabilizing systems are wired together so that stress in one place transmits mechanically and measurably into stress somewhere else. Which brings us to the 4th warning, and this one is different in character from the first 3 because it is not a single annual report or a single modeling study. It is something that unfolded in real time. across the opening weeks of 2026, and it was documented by the World Meteorological Organization alongside the Copernicus Climate Change Service, which is implemented by the European Centre for Medium-Range Weather Forecasts. According to Copernicus data, January of 2026 was the 5th warmest January on record globally. That alone might not sound alarming. 5th warmest out of roughly a century and a half of record keeping is still, after all, not the warmest. But the way that global average was assembled is what makes this warning distinct, because the same month contained wildly contradictory extremes happening simultaneously in different parts of the world. Extremes that only average out to 5th warmest because they were pulling in opposite directions at the same time. In the Northern Hemisphere, a meandering polar jet stream, the high-altitude river of air that normally keeps frigid Arctic air penned up near the pole, buckled and spilled icy air southward into both Europe and North America. Europe experienced its coldest January since 2010. National meteorological services across the continent issued multiple severe weather alerts, some reaching the highest possible danger to life warning level for extreme cold. Germany's National Weather Service, the Deutscher Wetterdienst, which also serves as one of the World Meteorological Organization's official regional climate monitoring centers for Europe, issued updated warnings as the cold snap intensified. At the very same time, in large parts of the Arctic itself, in Greenland and across western North America, temperatures were running above average, in some cases significantly so. And in the Southern Hemisphere, it was the height of summer, and record-breaking heat provided the fuel for extreme wildfires that broke out across Australia, Chile, and the Patagonia region of South America. So in a single month, the planet simultaneously produced its coldest January for one continent in over a decade, above-average warmth in the Arctic and Greenland, and record heat driving wildfires across an entire other hemisphere. And when all of that got averaged together across the globe, the net result was still the 5th warmest January ever measured. That is not a contradiction. That is precisely what a destabilized climate system looks like from the outside. It does not mean uniform warming everywhere, gently, predictably. It means a jet stream that used to behave in relatively stable patterns now buckling and meandering, delivering extreme cold to places that expect merely cold, while other places bake under record heat, and the wildfires, floods, and droughts that follow do not wait politely for a single global average temperature number to justify their existence. The World Meteorological Organization's own communications around this event made a point that connects directly back to the other 3 warnings, emphasizing that the accurate, timely forecasting and investment in early warning systems mattered more than ever, specifically because extreme weather in the first weeks of 2026 had already produced a heavy economic, environmental, and human toll. And this is worth pausing on, because it reveals something important about why these 4 warnings triggered close together rather than being scattered randomly across different years. Early warning systems, the actual infrastructure of weather radar, satellite monitoring, flood sensors, and public alert networks exist specifically because the underlying hazards they are built to detect have become more frequent and more intense. The United Nations has been pushing an initiative called Early Warnings for All, launched by the Secretary General in 2022, with a goal of ensuring that every person on Earth is covered by a multi-hazard early warning system by the end of 2027. As of the most recent report, 119 countries now have such coverage, which actually represents a 113% increase since 2015. That sounds like remarkable progress, and in one sense it is, but read it again and notice what it implies. Coverage had to more than double in a decade because the hazards these systems are meant to catch have themselves been intensifying so quickly that roughly half the world was previously left exposed with no meaningful advance notice at all. Research cited by these early warning efforts found that the intensity of heavy downpours in some regions has increased by 40% since pre-industrial times, with certain areas now receiving more than a year's worth of rain within just a few days. Giving people just 24 hours notice before a hazardous event, according to the same body of research, can reduce the resulting damage by roughly 30%. And every $800 million invested in these warning systems in developing countries is estimated to prevent $3 to $16 billion in losses annually. The infrastructure of warning is racing to catch up with the acceleration of the hazard, and that race is precisely why 4 separate scientific warning systems, tracking 4 separate aspects of the planet, all lit up within months of each other. They are not 4 coincidences. They are 4 different instruments measuring the same accelerating trend, calibrated to notice slightly different symptoms of it. Step back now and look at what these 4 warnings actually are, side by side, because the pattern only becomes fully visible when you hold all 4 together at once. The first warning tells you that the fundamental chemical and physical boundaries that kept Earth stable enough for civilization are falling one after another, 7 down, 2 to go, and the newest one to fall was the ocean itself turning measurably more acidic. The second warning tells you that one of the specific mechanical systems threatened by that instability, The Atlantic Ocean's great overturning circulation has likely already lost its safety net, its path back to recovery closed off by atmospheric carbon dioxide levels that have already been exceeded. The third warning tells you that when you step back and measure the planet's overall vital signs across 34 separate categories spanning climate, oceans, energy, and food systems, the majority of them, 22 out of 34, are sitting at the most extreme levels ever recorded. And the report's own authors describe the planet as being on the brink. The fourth warning tells you that this is not abstract or confined to slow-moving annual data sets. It is already showing up in the weather. People are living through right now in a single month, capable of producing record cold in one place and record heat driving wildfires in another, a signature of instability rather than simple uniform warming. None of these four warnings came from the same lab. None of them were coordinated as some kind of unified messaging campaign. The Planetary Boundaries Assessment comes out of the Potsdam Institute and the Earth Commission. The AMOX study was published independently in a specialized ocean and earth science journal. The State of the Climate Report is led by ecologists and physical scientists at Oregon State University, working with an international coalition. And the January 2026 extreme weather data comes from the operational monitoring work of the World Meteorological Organization and Copernicus, agencies whose job is simply to measure what is happening, not to make an argument about it. 4 separate institutions, 4 separate methodologies, 4 separate publication timelines, and yet the same handful of names keep reappearing across them. Johan Rockström threading through the Planetary Boundaries work in the AMOC study, the Potsdam Institute contributing to both the Health Check and the State of the Climate Report, because the scientific community working on Earth systems is not actually 4 separate communities. It is one relatively tight-knit global research effort, looking at the same planet from 4 different instruments, and in early to mid-2026, all 4 instruments returned readings that pointed in the same direction within a matter of months. That convergence is the real story here, more than any single number. If only one of these 4 reports had come out, you might reasonably treat it as one data point among many, a single study to be weighed against uncertainty, against natural variability, against the normal caution that should accompany any single piece of scientific evidence. But 4 independent lines of evidence using different data, different time frames, and different methods, converging on the same underlying conclusion that the systems regulating Earth's stability are under simultaneous, escalating, and interconnected stress is a much harder thing to write off as noise. Scientists themselves describe this using the language of cascades and interconnection specifically, because that is what the data shows them, not because it makes a better story. The planetary boundaries were designed from the outset to interact. The AMOC's fate is explicitly tied to Greenland's ice sheet and the Amazon's moisture supply. The State of the Climate Report explicitly names the AMOC as one of its watched tipping elements, and the extreme January weather is the visible, lived experience of a jet stream destabilized by exactly the kind of warming these other reports are documenting mechanistically. Pull on any one thread, and the other 3 move. Consider for a moment how differently this story would read if these 4 warnings had arrived a decade apart from each other, instead of within the same handful of months. A planetary boundaries update in 1 year, an ocean current study 5 years later, a vital signs report a few years after that, and an unusual weather month sometime further down the line. Each one would likely have been absorbed into public consciousness as its own isolated event, discussed for a news cycle and then set aside. That is, in fact, roughly how climate reporting has often worked for decades, one alarming study at a time, each one competing for attention against the last, each one fading before the next arrives. What makes early to mid-2026 different is the density. 4 major, independently produced, scientifically rigorous warnings essentially stacked on top of each other within the same compressed window, each pointing at a different piece of the same underlying machinery. That density is itself informative. It suggests the system being measured is not merely trending in a worrying direction over long timescales, but is now close enough to multiple thresholds simultaneously that independent research groups, without any coordination, keep bumping into significant findings at almost the same time, the way multiple people in a dark room might all reach the same wall from different directions within moments of each other, simply because the room has gotten that much smaller. It would be easy to end a story like this on pure alarm, and it would also be incomplete, because every one of these 4 source reports, even the most sobering, pairs its warning with an explicit statement that the trajectory is not fixed. The scientists behind the State of the Climate Report are explicit that climate mitigation strategies exist, are cost-effective, and remain capable of limiting warming, provided action is bold and swift, and they say the window for that action is closing but is not yet shut. The Planetary Health Check authors describe the window for returning to a safe operating space as still open, even while stressing that it is closing fast. The Montreal Protocol is repeatedly cited across this research as living proof that coordinated global action on a planetary boundary process can actually work, given that nearly 200 nations came together to address damage to the stratospheric ozone layer, and that layer is now measurably recovering, one of only 2 boundaries still inside the safe zone specifically because of that intervention decades ago. And the entire architecture of the early warnings for all initiative exists because early information saves lives and money right now, today, even without solving the underlying cause, buying time and reducing harm while the harder, slower work of addressing emissions continues. There is also an economic dimension to all of this that rarely makes it into the headlines, but that analysts and institutions well outside the climate science world have started to quantify in blunt financial terms. Organizations that study global economic risk have pointed out that trillions of dollars in economic value generation depend, directly or indirectly, on the stability of natural systems, the same systems described by the Planetary Boundaries framework. When a boundary like ocean acidification falls, it is not only marine biologists who take notice. Insurers begin repricing risk in coastal and fishing-dependent economies. Supply chains tied to agriculture start factoring in a wider range of possible disruptions. Central banks and financial regulators in several countries have begun explicitly modeling climate-related physical risk alongside more traditional financial risk, because the two are no longer treated as separate categories. The fragility of the global economy, the vulnerability of energy security, and escalating climate risk are now routinely listed alongside geopolitical rivalries and conflict as top-tier risks facing the next several years, not because economists have suddenly become climate scientists, but because the physical instability documented in these 4 warnings translates, fairly directly, into financial and social instability. A weakened ocean current, a crossed chemical boundary, a planet with the majority of its vital signs at record extremes. These are not confined to laboratories and journal articles. They move through insurance premiums, through food prices, through the cost of rebuilding after disasters, and through the calculations governments make about where people can safely continue to live. So why did 4 global warning systems trigger at almost the same moment? Not because of coincidence, and not because scientists suddenly decided to sound more alarmed. They triggered together because they are all measuring facets of a single physical system that has been pushed over the course of decades closer to several interconnected thresholds at once, and 2026 turned out to be the year several of those separate lines of evidence happened to cross into publication and into public record within months of each other. A boundary in ocean chemistry that had been approaching its limit for years finally tipped. A modeling effort that had been building for years finally produced a definitive answer about the AMOC's point of no return. An annual health check that has been tracking the same 34 indicators since 2020 hit its highest concentration yet of records being broken. And a jet stream, already known to be affected by a warming Arctic, produced a month extreme enough in enough directions at once to make global headlines on its own. 4 instruments, 1 underlying signal. And the fact that they all sounded within the same stretch of months is not proof of some sudden new catastrophe arriving out of nowhere. It is proof that the Earth's various stabilizing systems are close enough to their thresholds and connected closely enough to each other that stress in one area is now visible almost everywhere else, nearly simultaneously, the way a single crack traveling through glass will eventually reach every edge of the pane at once.